Welcome back to Foundations of Data Science for Psychology. In this lesson, we're going to continue talking about the components of object-oriented programming, and we'll discuss behavior objects and operators. So for review, let's discuss all the main components of object-oriented programming. What are we actually working with? In the previous lecture, we discussed data objects, including the types of data that we use and the structure of the data. So what format are they in? Those are the data objects of object-oriented programming. Today, we'll talk about behavior objects, i.e. code objects, which are functions, commands, statements, and scripts. So actually the instructions for what to do to the data objects. We'll also discuss operators, which are neither data objects nor behavior objects, but are other ways to manipulate data. So actually, we'll first touch on operators. So an operator is a symbol that tells the compiler to perform a specific mathematical or logical manipulation or assign data to an object. And these are most likely already familiar to you. Arithmetic operators are mathematical operators. So the mathematical operators that you're familiar with: addition, subtraction, multiplication, division, modulo. This double percentage sign is called modulo, which returns the remainder of a division operation. The caret is raising an exponent, and then of course parentheses. And arithmetic operators act on each element of a vector, so you can apply these operators to lists, and it will do the same operation on each element of the list. And just as in math and algebra, the order of operations from arithmetic applies. So PEMDAS, you can use your programming environment just the same way that you would use a calculator or other program and sort of create equations that follow the order of operations. Relational or logical operators are for testing conditionals, and the result of a relational or logical operation results in a logical or Boolean value, so true or false. And you're probably already familiar with these operators, so greater than, less than or equal to, greater than or equal to, equals to, or not equals to. So the exclamation point with the equal sign is not equals or does not equal. And so if you create a logical statement with one of these operators, the result will either be true or false. So that's the value that will be returned. And lastly, there are assignment operators, which we discussed in the last lecture. These are used to assign variables to scalars and vectors. So in R, the most common assignment operator is the leftward facing arrow, but you can also do the same thing in the rightwards direction or use double arrows. They all do the same thing. In Python, the convention is to use an equal sign, although you can also use an equal sign in R. There are just a bunch of different ways to assign data to some object that you're naming in variable assignment. So these are invariant. They are just operators that are used to manipulate data objects and code objects. So for example, assignment operators could be equal sign or the leftward facing arrow. So assigning 6 to y, or sorry, 6 to x or 8 to y. Arithmetic operators, so x plus y. In this case, if x was 6 and y is 8, x plus y would be 14. And then relational operator, so we could create the statement x greater than y, and it would return the logical or Boolean value of false. Hopefully that's pretty self-explanatory, and there'll be lots of practice of this in today's in the script that follows along with today's lesson. Okay, so let's talk about behavior objects, also known as code objects. So in object-oriented programming, code objects operate on and manipulate the data objects. they're sort of the instructions for what to do to the data objects. And it's helpful to think about in the context of the syntax of these languages, sort of what function or sort of what role each of these different kinds of behavior objects are playing. So the main types are functions or commands, and these are sort of acting like verbs in sentences and in the syntax of these languages. So they sort of are describing some operation to do some function, and they're sort of the verb, they're sort of the action. Statements are kind of like phrases and sentences, so they may include one or multiple functions or commands in a single line of code, as well as other operators. And then scripts refers to the sort of the entire document. So a full document in a scripting language that you would save under a name, and you could call and sort of open up that script and run your code and sort of save it the same way that you would save a text document on your computer. And it may be sort of unintuitive to think about these things as objects, but they are objects because they can be assigned to a variable name, stored and referenced using that name. So the same way that we can create a list that's called X and we can give it some values, we can also create functions, create statements, create scripts, and name them. And through that assignment, when we call the name of that function, statement, or script, those operations will be performed. So it's sort of another way of saving and referring to information in the context of manipulating data. So let's talk about each of these things in a little bit more depth. The first and sort of most lengthy explanation we'll provide is about functions. Functions are sort of the backbone of programming. And functions are really include a set of instructions for manipulating a data object or multiple data objects. And when you call a function by its name, that set of instructions is performed. So it's sort of a way of saving and enacting a set of operations in a shorthand way. And it's kind of like a recipe. So we introduced this metaphor in the last lecture of sort of creating recipes from the ingredients, the data objects, with the set of instructions, meaning the behavior objects. So functions take in ingredients, they take in the data objects, perform some operation or operations, and then return some result. And different functions require different types and amounts of data. So some functions are very simple. Maybe they only take one ingredient. They are just performing one operation on a single data object, whereas some are more complex. They take in multiple data objects because the operation performed includes multiple data objects, and maybe there's different settings that you can turn on or off to get different outcomes. So there's definitely a range of complexity of functions. So for example, and these are sort of made up silly examples just to get the point across, but you can imagine a function called toast, and it just takes the data object bread. So you tell it to basically toast bread. So bread is a data object and toast is a function that performs some action on it, like a verb. On the other hand, you can have functions that are more complex that include lots of different data objects because what they're doing requires more ingredients. So for example, making pie. The verb of making pie, the action of making pie involves more than one ingredient. It involves at least apple, spices, butter, flour, salt, baking soda, egg wash, et cetera, et cetera. And it would be doing a variety of operations on those data objects to return the final result of pie. So it's a more complex action. Okay, so functions can be identified by the fact that they end in parentheses, and this is invariant across across programming languages. So for example, print parentheses, view parentheses, mean parentheses, where you put something in the parentheses so that that action is performed on that data object. So inside the parentheses, you specify the data objects and other specifications that the function requires in order to perform the defined computation or task. And so all of the things that you put inside the function that the function will refer to in the performance of that operation are called parameters or arguments. So in this same example, in the make pi function, everything inside of the parentheses is a parameter or argument. So apple, cinnamon, butter, flour, those are all data objects. And then bake is a specification. It's a setting that you are providing the function. So it will perform the operation a little bit differently depending on what value you give that specification. So let's talk a little bit more about these arguments or parameters. And we sort of use those two terms interchangeably. In R, technically they're referred to as arguments. In Python, they're called parameters, but there's really no difference. They refer to the same thing. It's the stuff that goes in a function. And these include the data objects that will be used or manipulated, but also any additional settings that need to be indicated, like I just said. So again, in this example, everything inside of the parentheses is an argument or parameter. It's either a data object that the function needs in order to operate or some setting that needs to be indicated on, off, or be provided some value. So here, you're giving the function apple pie all the ingredients it needs, but then you're also specifying additional specifications that will change the nature of the outcome. So here you're saying that you want to bake it at 350, the top should be a lattice top and burned crust is off. So you don't want a burned crust. And again, these are made up examples just to illustrate the point. Another point here is that there's a distinction between using existing functions, so functions that already exist or that other people have written, versus writing your own functions. In the beginning, you are mostly going to be using existing functions. In R and Python and MATLAB, there are tons and tons and tons of functions that already exist. So there's not really a big need to ever write functions to get what you need to done. So the existing functions come with either the base language, meaning when you download the language itself on its own, it has a lot of functions in it. So, and we call that language that's downloaded without anything added to it, the base version of that language. So base R or base Python. But then to base R or base Python, you can download and integrate other packages and libraries. So sort of tools that other people have written and sort of suites of functions that other people have written for particular tasks. So if you can imagine it, someone probably has written a function for it or have created a package that has lots of functions or related functions in it that you can download and then use. So those don't come with base R or Python, but they're very easily accessible. And we will be showing you how to download packages and libraries in the next lecture. And the way that you know sort of how to use a function and what parameters and arguments it needs is by reading its documentation. Documentation refers to just descriptions of the code base and how it works that are written by the people who wrote that function or wrote that package. And the way that you access or find documentation for a particular function is either first just Googling it, or Googling the name of the function, the name of the package or library that it came from, or use the help menu in the IDE that you're working in. So the integrated development environment, there's always a help window where you can search the name of a function and it will tell you and bring up the documentation so that you know what the function needs in order to run. But you can also write your own functions. And what this looks like is basically you're assigning a block of code to a function name so that it's automated. So if you want to automate a few lines of code, you can write it as a function. You can assign that block of code a name so that when you call that function, it executes those lines of code. So you could define a function called my recipe. You could specify the ingredients you need, and you can specify what the function does. And then instead of running that block of code, you could just call the function. So you're sort of making it more efficient by doing that. You don't need to do this, but it may be something that you want to do when you sort of get a little savvier, and or if there's anything that you come across that there's not already some perfect function for. So basically, to continue with the cooking metaphor, defining a function is kind of like defining a recipe. So you're packaging it up and you're assigning it a name, and then you're calling that name. It does everything in that little block of code. And we will cover how to actually do this later in the course. Okay, so moving on to the rest of the kinds of behavior objects, commands and statements. So a command is sort of used synonymously with the term function, but what it really refers to is a function that has its specified arguments or parameters. So not just print, but print X, right? That's a command. You're sort of commanding the computer to print X, or mean of list one. So generate the mean of list one, or R core list one, list two. Find the correlation between list one and list two. So that's a command. And then a statement is a single line of code that can include multiple commands and operators. So you can include multiple functions, multiple operations. This is sort of a single line. So it's like a phrase or a sentence. So for example, new value is being assigned the value of the square root of X plus 78. So there's a command in there, there's a mathematical operation, there's an assignment operation. So then it becomes a statement. It's sort of just the next in terms of length. And then lastly, there's scripts. And you should already sort of be becoming familiar with the concept of a script. It's a text file containing a set of commands, statements, and comments. Scripts are sets of instructions for completing some programming task, and usually it requires multiple functions, operations, and steps. So it's sort of a Word document or a text document that includes multiple lines of code, and you can save the script under a name and call it up and deploy it whenever you need. And sort of writing functioning scripts is really one of your main goals in data analysis, to automatize your data analysis process. And then let's just also talk about comments. So comments are text in a script that are not read by the interpreter or executed. So it's you writing information, usually in plain English, so that you can actually understand what the code is doing. So you're adding descriptions of the code or just text that the interpreter or compiler won't try to read as code. In R and Python, comments are marked using the hash sign or the number sign. And you can see here in this script, everything that starts with a hash sign ends up being in green. That means it's a comment and it is not going to be read by the interpreter or compiler. So it's like a description of what's going on. And it's really helpful to just leave yourself lots and lots of comments so that you don't need to guess at what you are trying to do the next time that you open your document, or if you share the script with other people. So your instinct as you're starting out should really be to comment excessively. Okay, so let's bring it all together. Let's say that you have a data object, you have a list called my apples, and it is a list that includes 2 character or string values, Granny Smith and Fuji. Okay, so we have a list of apples called my apples. Let's talk about some code objects that can be used with my apples, the data object. Okay, there's a function called bake, right? You could bake the apples. So we know this is a function because it has parentheses after it. This could become a command by using my apples as a parameter to the function bake. So now you're baking my apples. And what that will do is it will perform the bake function to each element of that vector, of which there were two. You could create a statement where you're seeing which of the scalars in the list my apples is equal to Fuji. And so we know that one of them is. Which is it? And that will return the index of the location in the list where the value Fuji is. We could add an additional argument to the function bake if it calls for it, right? So bake my apples, but we could also turn on cinnamon. Cinnamon equals true, which could mean something like the cinnamon specification is being turned on. So you want your baked apples to include cinnamon. You could define a new function that looks for which of the apples in my apples is called Fuji and then only bake that apple. So this is what it looks like to create a new function if you felt like it, if you felt like having a function that was so specific about baking the Fuji apple. And then you could name this whole script bakedapple.r, and then you could save that script and you can open it up later. Okay, so hopefully that's given you a bit of an overview about the nature of behavior objects, code objects. So you have all the pieces. So now let's open this week's scripts to practice data types and structures, code objects, and operators in both R and Python.